Okay, for the fourth problem on the back page, we have part A, which is exactly the same as number 1. Go ahead and do that on your own. We'll cover that tomorrow in class if you have questions. Part B for number 4, however, is a little bit different. If we draw a free body diagram for part B, now this bar is at an angle. We still have the 900 newtons down, and we still have a tension pulling up in this direction. But now our bar is pushing upwards also. So it's not perfectly horizontal anymore. We'll call that force bar. Now, it's a little bit tricky to find these angles. Here you have to have a little bit of triangle knowledge. We have a 6, a 5, and a 2 length on our sides of this triangle. I clearly didn't draw that to scale. How might we figure out the angles of that triangle? Think about that for a second. Pause the recording for a while and talk about it together. How can we calculate those angles? Did you come up with the method? One way that I thought we could do things was to say, use the law of cosines. C squared is a squared plus b squared minus 2ab cosine of c. We know all 3 of these sides. And so the only variable then is some angle c. And you can pick any one of those angles and calculate what that might be. You might calculate this angle. You might calculate that angle. You might calculate this angle. Or you could do all 3 separately, different calculations. Now that will give you these different angles here. It's still going to be a challenge to figure out the x and y components of those 2 forces. I want you to try that for tomorrow. See what you can do. My guess is you'll have to set up multiple equations and solve for some variables and substitute into other equations. But we'll pick this up on Friday and do this problem together. Okay. Good luck.